Welcome for today's class of mathematics. Today's question is taken from Ganita Prakash, class 8, a square and a cube chapter. So take down the question, how to check if a number is a perfect square. Okay. So there are 4 methods to find this. Let's start each one of them. So first method will be, you'll have to list all the square numbers. List all the square numbers. Okay. So we know that perfect square can only end in certain digit like 1, 4. So we know that perfect squares can only end in certain digit. One comma 4 comma 5 comma 6 comma 9 or an even number of 0. But this rule only helps us to eliminate some numbers. Okay, so but this rule only helps us to eliminate some number of zeros. Okay, wait 1 4 5 and even number of zeros, but is some numbers, wait, some numbers, it doesn't confirm a square, wait, some numbers, wait, not this one. Okay, write down, it doesn't, refer your textbook. Okay, it doesn't confirm a square. You can write down, for instance, it's obvious that 327 is not a perfect square. Because it ends in 7. However, a number like, however, a number like 576 ends in 6, so it might be a square. To be sure, we need to check further. Okay. So one method is to list nearby perfect square. One method is to list nearby perfect square now. Since 20 square is equal to 400. We check the few squares like 21 square, which will give you 441. Then we have is 22 square, which will give you 484. Then we have is 23 square, which will give you 529. Then 24 square, which will give you 576. Right? So thus 576 is indeed a perfect square. Is a perfect square also you can write down. Okay, is a perfect square. So however you all can write down, however this method becomes slow and impractical for very large numbers. More efficient techniques are needed to test whether big numbers are perfect square. Okay, next is by successive subtraction of odd numbers. So next let me write down by successive subtraction of odd numbers. So you'll have to remember that any perfect square can be written has the sum of consecutive odd numbers starting from 1. Okay, so example, take the number. Okay, so I will be giving you all this topic in the next class, or this class only better I'll give you all. So example, let me give you all. You all have to take the number 81 as an example. Like 81 minus 1 is equal to 80. Then 80 minus 3 will give you 77. Then 77 minus 5 will give you 72. Then 72 minus 7 will give you 65. Then 65 minus 9 will give you 56. 56 minus 11 will give you 45. Then 45 minus 13 will give you 32. 32 minus 15 will give you 17. And 17 minus 17 will give you 0. So we subtracted consecutive odd numbers beginning with 1 and reached 0 in the ninth term. Yes, but can we apply the same method for root 729? Yes, but the process would take very much time. Next class I will be giving you all by prime factorization method. Okay. This also I will continue along with, I will explain you all this concept also along with the prime factorization method, which will be in the next class. Okay, thanks for watching. Don't forget to like, subscribe my channel, share with your friends, press the bell icon for more updates. If any doubt, queries, comment below.